Okay, so this is Jacob's Algebra, Chapter 9, Lesson 2. I don't think I'm going to manage to get this one all in one video either, so there will probably be a part 2. This lesson is about polynomials. Remember in the last lesson we learned about monomials. A polynomial is a monomial or expression showing the addition and or subtraction of two or more monomials. The degree of a polynomial is the degree of the highest degree term. Now, the degree only applies to variables. So if we have x cubed plus 8, there are two terms here. We have two monomials, x cubed and 8. Our highest degree term is the x cubed, so that has a degree of 3. If we have 2x to the 5th plus x to the 4th minus 1, we have three terms here because we have three monomials that we are adding or subtracting. So there are three terms. Our highest degree term is 2x to the 5th, so our highest degree is 5. Now, what if we have something like 2 to the 3rd x? Okay, our highest degree term is actually the x, and that is 1. So our degree is 1. We have only one term here. We don't care if there is an exponent on a number because we can change that to just 8x. We do care when the exponent is on a variable. So when you're looking at what is the highest degree term, only the exponents that are applied to variables count, not exponents that are applied to numbers. Okay, so let's start with number 4. Number 4 says, tell whether or not each of the following expressions is a polynomial. So for part A, we have 5x squared plus 10x. That's supposed to be a plus. A polynomial is when you add or subtract, it's a monomial, or when you add or subtract one or more monomials. Well, we have two monomials there, so this is a yes. We can look at part C. Part C says x to the minus 3 plus 1. X to the minus 3 is not a monomial because the exponent here is negative. So this is not a monomial. So you would say no, the expression is not a polynomial. Okay, so let's look at part E. We have 1/2 x to the 10th plus 2/3 x to the 5th minus 3/4. This is a polynomial. Each of these terms, and there are three terms here, each of these terms is a monomial, so this does qualify as a polynomial. Let's look at part F. We have 10 to the x minus 5. This is not a polynomial because 10 to the x is not a monomial. We cannot have our x be the exponent. X has to be our variable. Okay, so now that was number 4, which is just like number 11. So now we're going to look at number 5, which is going to be just like number 12. And that says write each of the following polynomials as a sum of monomials. So for part A, we have x cubed minus 4. When we write that as a sum of monomials, that's just x cubed plus negative 4. Whoops, I lost my negative. Okay, part B, we have 1 plus 2x minus x squared. To write that as a sum of monomials, we would say 1 plus 2x plus negative x squared. And then part C, we have negative 5x minus 10. Writing that as a sum of monomials, we have negative 5x plus negative 10. So that was number 5, which is just like, number 12. Okay, the next one we're going to look at is number 6. Number 6 is just like number 13. It says rewrite each of the following polynomials in descending powers of the variable. So what that means is we're going to start off by writing down the polynomials. So for part B, we have 3 minus 7y plus 5y squared. And what we have to look at is the degree of our variable. What is our highest degree that we have? It's the 5y squared. So that's the term we have to put first. What you have to remember when you're doing this is that the sign in front of your monomial belongs to the monomial. So this is a plus 5y squared. Now, what's the next smaller one below that? That would be 7y, which is to the first power. Notice it has a negative in front of it. So now we say minus 7y. And then what's left is our constant, the 3. There is no sign in front of it. When there's no sign, it's understood to be positive. So this is plus 3. So 5y squared minus 7y plus 3 is rewriting the polynomial in descending degrees, descending powers of the variable. So now we're going to look at part E. For part E, we have 5x to the 4th plus 20 minus x to the 6th minus 2x to the 8th. Our highest degree term here is 8, and that is negative 2x to the 8th. Remember, we have to take the sign in front of it also. So we're going to start with negative 2x to the 8. Our highest exponent that we have now is 6. So negative x to the 6th comes next. Now our highest exponent is x to the 4th. So we're going to add 5x to the 4th. And then the only thing left is our 20, which is positive. So remember, you have to grab the sign in front of your term because that sign belongs to the term. Now part F, we have 2 to the 5th plus y. Remember that exponents don't count unless they're attached to a variable. This 2 to the 5th plus y, that could be written as 32 plus y. Our highest degree term is the y, which has a degree of 1. So we would write this as y plus 2 to the 5th. So be careful when you see the exponent. Don't just grab the highest exponent. The exponents only count when, in terms of writing it in descending degrees, the exponents only count when they're attached to a variable, not when they're attached to a number. Okay, so that was number 6, which is just like number 13. Next, we're going to do number 7. Number 7 is just like number 14. It says use the distributive rule to write each of the following as a sum of monomials. So we're going to try part B, which is negative 5 times y squared minus 1. So negative 5 times y squared is negative 5y squared. Negative 5 times negative 1 is a positive 5. So be careful when there's a negative in front, that negative is still attached. Negative 5 times y squared is negative 5y squared. Negative 5 times negative 1 is a positive 5. Okay, the next one we're going to do is part D, which is 3x times x squared minus 2x plus 5. So we're going to multiply 3x by every term that's inside the parentheses. So 3x times x squared is 3x cubed. Because we had x to the first power, we add our exponents. Then 3x times negative 2x is negative 6x squared. We're multiplying our coefficients. 3 times 2 is 6. Well, 3 times negative 2 is negative 6. And then we add our exponents. X to the first power times x to the first power is x squared. And then our last term, 3x times 5, is just 15x. Okay, then we're going to do part F, which is negative 4y times y to the 4th minus 2. So negative 4 times y to the 4th is negative 4y to the 5th, because our y is over here is to the first power. 1 plus 4 is 5. Then negative 4y times negative 2 is going to be a positive 8y. So that was number 7, which is just like number 14 in the homework. Okay, moving on, let's look at number 8. Number 8 is just like number 15. It says, like the opposite of a number, the opposite of a polynomial is the polynomial that results from multiplying it by negative 1. So what you do when you need to multiply something by a negative 1, or you need to get the opposite, change every sign. If it was a positive, make it a negative. If it was a negative, make it a positive. So we're going to do part C here. Part C is negative 6x squared plus 11. And what we need to do is write the opposite of it. Just change all the signs. Negative 6x squared becomes positive 6x squared. Positive 11 becomes negative 11. So 6x squared minus 11 is the opposite. Part D, we have 1 minus 2y plus 3y squared, and then minus 4y cubed. We're going to change every sign. There is no sign in front of the leading 1 So it's understood to be a positive, so that positive 1 is changed to a negative 1. Our negative 2y becomes a positive 2y. Our positive 3y squared becomes a negative 3y squared. And our negative 4y cubed becomes a positive 4y cubed. So this is writing the opposite of a polynomial, which just means changing all your signs from positive to negative and from negative to positive. Okay, so now we're going to look at number 9. Number 9 is just like number 16 in the homework. It says the value of a polynomial in x depends on the value of x. So we're given a polynomial, and I'm just going to do this first one, x squared plus 7x minus 1. And we're told to evaluate it for several different values of x. So for part A, what if x is equal to 0? Well, I just plug 0 into my equation. 0 squared is 0, 7 times 0 is 0, and then minus 1. So we get negative 1. For part B, we need to do this for x equals 1. So 1 squared is 1, plus 7 times 1, that's 7, minus 1. 1 plus 7 minus 1, that is 8 minus 1, which is 7. Part C, we do this for x equals 2. 2 squared is 4. 7 times 2 is 14, so we're going to add 14, and then we subtract 1. 4 plus 14 is 18, minus 1 is 17. Okay, so now we do part D, which is x equals negative 1. Negative 1 squared is going to be a positive 1 because remember, negative numbers raised to an even power become positive. And then 7 times negative 1 is a negative 7. And then we subtract 1. So 1 minus 7 is negative 6. Minus another 1 is negative 7. And then part E, we have x equals negative 2. Negative 2 squared is 4. Again, our negative times negative becomes positive. And then negative 2 times 7 is negative 14. And then we subtract 1. Well, 4 minus 14 is negative 10, minus another 1 is negative 11. So that is all that you have to do for these. You write down your polynomial, and then you look at the values that you're asked to evaluate it for, and you plug that number in for x. Okay, so that was number 9, which is just like number 16. Our last one we're going to do is number 10. This is just like number 17. It says simplify each of the following polynomials by combining terms of the same degree. Write each answer in descending powers of the variable. So first we'll combine like terms, and then we will rewrite it in descending powers. So part A, we have 4x plus 6x squared plus 2x. Well, we do have two terms that have the same degree, 4x and 2x, so we can add those. So this becomes 6x plus 6x squared. But we want our highest degree term first, and that's our 6x squared. So we will rewrite this as 6x squared plus 6x. Okay, the next one is we're going to do is part C, which is 7x squared minus 7x minus x squared. We do have two terms that have the same degree, 7x squared and negative x squared. So 7x squared minus x squared is 6x squared minus 7x. We're already written in descending powers of the variable because we have our second degree term first and our first degree term next. Okay, so the last one we're going to do here is part E, which is x to the 4th minus 4x squared plus 4 minus 4x squared. Our terms that have the same degree are powers of 2, so we have negative 4x squared and negative 4x squared. So we can rewrite this as x to the 4th, and then negative 4x squared and negative 4x squared is going to give us minus 8x squared, and then plus 4. It's already written in descending powers of the variable, so that's number 10, which is just like number 17, and I actually got the whole thing done in one video. So if you have any problems, just go back and look at the example problem from set 2, and then you'll be able to figure out what you're supposed to do for set 3.